Chapter 8 is all about the electron configurations. So here is one of the questions, number 66, in the back that asks about the electron configurations for anions and cations. So just ions, not just the regular elements. So how we start off with these, we would do the same thing. We start off with its original, like its parent element. So it's chlorine minus, we're going to write the electron configuration as if it was chlorine. So we would start off with, we can use the noble gas configuration. So the noble gas before is neon. And then after neon, we fall across the periodic table and we get 3s2, 3p5. So that would be regular chlorine, just zero charge, neutral chlorine. So then, how do we get to a negative? Chlorine negative means we've added one electron. So if we draw it out right, we would get our last two, 3s, and then 3p. So our 3s is completely full, and then our 3p is 1, 2, 3, 4, 5. So where would, this is for chlorine, remember. So let's write out chlorine negative. We're going to have the same thing, 3s2, 3p. Where are we going to add this one electron? It has to get added into this p, the last p. So it's going to get added right there. So that is going to be the negative electron, the negative charge, the extra electron. So that's how we're going to get the full 3p6. Right? It's to represent that sixth electron in the p orbital. So the same thing, well, kind of an opposite thing with molybdenum 3+. So this guy has a 3+ charge, and same, like, remember these are for anions. We've added an electron. For a cation, so a positive charge, we have taken away electrons, right? So that's in general for all cations. Okay, so molybdenum, if we go in the periodic table, the noble gas before it is krypton. So krypton, and we get, and remember molybdenum is also an exception. So we have neutral molybdenum is krypton. And then we have 5s1, 4d5. Sorry, lost my 5s. Remember, we have it as the 5s and the 4d. If it would have been 5s2, 4d4, we would have had a full and a almost half full. So our special case here, we have the 5d. So then, when we take away electrons, where are we taking electrons away from? The highest orbitals, the highest n. So for the 3+, we have to get rid of 3 electrons. So the 3 we're going to get rid of, the first one is going to be this guy, right? We have to get rid of the 5s. So we're going to have 5s0, and then we have to still get rid of 2 more. Any 2 in the 4d would work, right? They're degenerate. I'm just going to use the last 2 because it's just convention. So our final answer for molybdenum 3+ is going to be krypton 5s0, 4d3. Because we only have these 3 left. So again, if you have a negative charge, a positive charge, negative charge, you're adding electrons, positive charge, right? You've lost the negative charge. And this is the special case, molybdenum. We have krypton or tungsten, right? These all follow the same pattern because it's in the family. You want to create the full, or the half full, 2 half full at 5s and 4d.